In this video, we are going to take a look at finding the radius and interval of convergence of a power series. So when we talk about power series convergence, what we're really looking at is for what values of x does the power series converge. Some power series will only converge at their center. So if you look at it on a number line and you have the center at C, x equals C is the center, then that is the only point where the power series converges. Now, every power series will converge at its center. Some will only converge at the center. Some power series, however, will converge over an interval. So we have C, and of course it converges at C, but it also converges over an interval, let's call it plus or minus A. So from C to A and from C to negative A. This distance right here between C and A is the radius of convergence. So we could think of the radius of convergence as being in the absolute value of A, because this would be a negative A over here, but the absolute value of that is still the same as the absolute value of A over here. So that would be the radius of convergence. The interval of convergence would be the distance from negative A to A, but we don't know if it is an open interval or a closed interval until we test the endpoints, which I will do in the first example. The third example of convergence is that it might converge everywhere. So on a number line, again, you have your center C, and it converges at C, but now it converges everywhere, all the way up to positive infinity and all the way down to negative infinity. So those are the three possibilities, either at the center, over an open or closed interval, or everywhere. So let's take a look at an example. Determine the radius and interval of convergence of this power series. So we're going to use the ratio test to do this. And so remember, the ratio test says that we are going to take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. And we sometimes refer to that as p. And so in this case, we would have the limit as n approaches infinity of n plus 1 to the fourth times x to the n plus 1 divided by 7 to the n plus 1. And instead of dividing by a sub n, we will multiply by the reciprocal, which would be 7 to the n over n to the fourth times x to the n. Now, this is when we have to do a little simplifying. So this then becomes the limit as n approaches infinity. Not much we can do to n plus 1 to the fourth, but x to the n plus 1 can be broken up into x to the n times x, and then times 7 to the n. That would be what I have in the numerator, combining both fractions into 1. 7 to the n plus 1 would be 7 to the n times 7, and times the n to the fourth, and times the x to the n. Now we can see that some things cancel out here. So the x to the n's cancel out, the 7 to the n's cancel out, and so what I am left with is the limit as n approaches infinity of n plus 1 to the fourth x over 7 n to the fourth. Now, anything that is not an n, we want to pull out. So this x and this 7 we can pull out because it's not going to have any effect on the limit. We're taking the limit of the variable n as n approaches infinity. So let's just pull the absolute value of the x over 7 out. So times the limit as n approaches infinity of what's left over, And n plus 1 to the fourth and n to the fourth can be kind of rewritten as n plus 1 over n all to the fourth power. Now, the limit of this limit is going to be equal to 1. So we have x over 7, absolute value, is times 1, which is simply the absolute value of x over 7. All right, so now this, according to the ratio test, this will converge when it is less than 1. And so the absolute value of x divided by 7 has to be less than 1 to converge. And so we can rewrite that as x over 7 is less than 1 or greater than negative 1, or x is less than 7, greater than negative 7. All right, so this tells us the radius of convergence. So again, if we were to put this on a number line, the center of this was at 0. That was our center, so we know it converges at 0. And now we're saying it converges from 7 to negative 7. Now we don't know whether we include those endpoints or not, but the radius is definitely 7. The radius of convergence is 7. So now what we need to do is determine whether this converges or diverges at the endpoints. And so to do that, we are going to do what's called testing the endpoints. Testing convergence at endpoints. And to do that, we go back to our original series, which was n to the fourth x to the n over 7 to the n. And we are going to substitute in, first of all, x equals negative 7. So when we put in x equals negative 7, we're going to have a series that looks like this: n to the fourth, negative 7 to the n over 7 to the n. Well, that can be rewritten as n to the fourth times negative 1 to the n times 7 to the n all over 7 to the n. And now these cancel out. And so we have our series negative 1 to the n, n to the fourth. We have an alternating series. So let's go to the alternating series test to determine convergence. And so the alternating series test says we take a sub n equals n to the fourth, and we find the limit of that. So by the alternating series test, the limit as n approaches infinity of n to the fourth is infinity. It's getting infinitely large. In other words, limits does not exist. So it fails the first test for convergence of an alternating series. So since it does that, that means it diverges. So what does that mean? That means that it diverges at negative 7. Well, now let's do the exact same thing, but let's test positive 7. So now when x is equal to positive 7, we have the series n to the fourth, 7 to the n over 7 to the n. Well, that's pretty easy. They just cancel out. So we have the series n to the fourth. Well, by the divergence test, this is the limit. By the divergence test, if the limit does not equal 0, it diverges. Well, or if the limit does not exist. Well, since this is going to infinity, technically the limit does not exist. So I'm doing the divergence test. The divergence test says that if the limit of n to the fourth, what is the limit of n to the fourth? Well, that's infinity, which technically an infinite limit does not exist. So therefore, this diverges. So it diverges at x equals 7. So we knew that the radius of convergence was 7, and we originally had this interval. And so now what do we know? We know that it diverges at -7, which means we do not include the -7, which means we keep the less than symbol, and it diverges at +7, so we keep the less than symbol. Let's just say that it converged. For instance, if it converged at x equals 7, let's say, then we would have -7 is less than x is less than or equal to 7. So if it converges, we have to include the endpoint by putting in the equal sign. The same thing would be true with the -7. If it converged at -7, then we would put in the less than or equal to -7, and it would converge at both of those. But in this problem, it diverges at -7 and it diverges at 7, so we use only the less than inequality. Or in interval notation, it would simply be paren -7, 7. Down here, if it converged at both, it would be bracket -7, 7. And of course, it could converge at one endpoint and diverge at another endpoint.